June 4, 1944. About 150 miles off Rio de Oro, in what was then Spanish Sahara, the Atlantic Ocean was a slate of gray. The Atlantic Ocean was a slate of gray hiding a predatory steel tube beneath the surface. Just after 1100 hours, around 1110, the sonar operator aboard the destroyer escort USS Chatelain reported a sharp, metallic ping. It was a sound that froze the blood of every sailor in the convoy. This was not a biological echo from a whale or a thermal layer anomaly. It was the distinct, hard return of a German hull. Task Group 22.3, a hunter-killer force led by Captain Daniel Gallery, had been stalking the specific quadrant for days, but finding the enemy was only the first variable in a complex equation of ballistics and acoustics. The Chatelain immediately surged to flank speed, her screws churning the water into white foam as she closed the distance. The logic of anti-submarine warfare is brutal. You do not wait for the enemy to fire. You flood the ocean with high explosives until the pressure waves crack the steel ribs of the target. Within minutes, the Chatelain attacked with hedgehogs, then rolled in with Mark 9 depth charges, each carrying about 200 pounds of torpex, set to explode at a chosen depth. As the canisters rolled off the stern racks, the physics of the engagement shifted from a hunt to a bludgeoning. The shockwaves slammed against the submerged hull of the German U-boat, identified later as the U-505. Inside the submarine, the concussive force felt like a sledgehammer striking the inside of a church bell. Lights shattered, flanges leaked. The hydraulic lines controlling the dive planes ruptured. The German commander, Oberleutnant Harald Lang, had no choice. The mathematics of buoyancy were failing him. With the pressure hull compromised and the rudder jammed, he ordered an emergency surface. He blew every ballast tank simultaneously. Compressed air screamed into the flooding chambers, displacing tons of water in seconds. On the surface, the American sailors watched the ocean boil. Then, the black snout of the Type 9C U-boat breached the waves, shaking off thousands of gallons of seawater like a wounded leviathan. This was the moment of standard doctrine. In 99% of naval engagements, the surface ships would now open fire with 5-inch guns and 20mm cannons to shred the hull and send the Nazis to the bottom. But Captain Gallery had a different, more dangerous calculation in mind. He knew that inside that failing steel shell lay the holy grail of naval intelligence. The Enigma machines, the current codebooks, the grid maps for the entire U-boat fleet. If they sank the sub, that intelligence would dissolve in the salt water. If they captured it, they could break the German naval code wide open. Gallery grabbed the radio handset and barked a command that had not been heard in the U.S. Navy since the year 1815, away borders. He was ordering his men to storm a live enemy warship. The Germans, however, were executing their own final protocol. As they scrambled out of the conning tower under heavy small arms fire, they were not just abandoning ship, they were scuttling it. The standard German procedure for a compromised U-boat was efficient and irreversible. Open the vents, smash the gauges, set the time-delayed charges, and most critically, open the sea strainers to flood the bilges. A whaleboat from the USS Pillsbury raced across the chop, carrying a small boarding party. They were heading straight into the mouth of a dying machine. The U-505 was not sitting still. It was circling erratically at 5 or 6 knots, rudder jammed to starboard, its wash threatening to swamp the boarding boat. As the Americans leaped from their boat onto the slippery, oil-slicked deck of the submarine, they were not greeted by surrender. They were greeted by the sound of rushing air and the ominous groan of metal under stress. The conning tower was empty. The hatch was open. Looking down into the darkness of the control room, Lieutenant Junior Grade Albert David saw water rising fast. He made the decision to drop into the hole. He knew the boat could be rigged with demolition charges and that any one of them could turn the control room into a furnace. He had to find them and disarm them before the timer reached 0. But as his boots hit the deck plates of the control room, he realized the water was not just rising from the leaks caused by the depth charges. It was surging in with the violence of a fire hose. The Germans had opened a valve that connected directly to the Atlantic Ocean, and the handle to close it was nowhere to be found. The mathematics of a scuttled submarine are terrifyingly simple. On U-505, the sea strainer cover was about 15 inches across, and when it was off, The Atlantic had a straight path into the bilges. At the surface, with zero hull pressure, opening this valve allows gravity to feed water into the bilge at a rate of gallons per second. But as the boat sinks, every foot of depth adds 0.44 pounds per square inch of pressure to that column of water. By the time the keel drops 20 feet, that intake becomes a hydraulic cannon, blasting hundreds of gallons of seawater into the hull every minute. When motor machinist's mate Zenon Lukosius entered the aft engine room, he walked into a deafening roar. The space was a chaotic tangle of diesel fumes, spraying oil, and the violent white noise of the Atlantic Ocean invading the ship. The German crew had executed their sabotage with German precision. They had not just opened the valves, they had unscrewed the heavy steel cover of the main sea strainer and discarded it. A solid column of water, 6 to 8 inches across depending on the account, was jetting up from the bilge, hammering the overhead and flooding the compartment. This was not a leak. This was a catastrophic breach. The water was already swirling around Lukosius's knees. He knew the physics of buoyancy were working against him. The U-505 was currently neutrally buoyant, hovering between sinking and floating. But for every cubic foot of air displaced by water, the boat lost 64 pounds of lift. The submarine was becoming heavier by the second. While Lukosius fought the water in the engine room, Lieutenant Junior Grade Albert David was waging a different war in the control room. The Germans had set scuttling measures and demolition charges, and the boarding party had to hunt them down fast. These were canisters of high explosives wired to timers. David knew he was standing inside a massive pipe bomb. He moved with cold, methodical speed, ripping wires from terminals and throwing the charges into sacks. He was gambling his life on the assumption that the Germans had set long fuses to allow their own crew to escape. Every second he spent searching for the hidden explosives was a second the boat slipped deeper. Back in the engine room, Lukosius realized he could not simply plug the hole. The pressure was too great for a wooden bung or a rag. He needed the original steel cover. He dropped to his knees, submerging himself in the oily, freezing slurry of the bilge. He groped blindly along the steel deck plates, his hands numb, feeling for the heavy metal disc the Germans had thrown away. His fingers brushed against cold steel. He found it. He hauled the heavy cover up, fighting the drag of the water. Now came the impossible part. He had to place the lid back onto the strainer housing, but the geyser of water coming out of the pipe was pushing up with tremendous force. It was like trying to cap a fire hydrant while it was fully open. Lukosius braced his boots against the diesel engine block. He leaned his entire body weight onto the cover, pressing it down against the uprushing jet. The physics of the situation required perfect alignment. If he stripped the threads on the butterfly nuts, the cover would never seal and the boat would be lost. The water sprayed into his face, blinding him, but he worked by tactile feel alone. He located the first bolt. He spun the wing nut. It caught, then the second, then the third. He grabbed a wrench and torqued the nuts down, crushing the gasket against the housing. The roar of the water changed pitch, then strangled into a hiss and finally silence. The immediate flow was stopped. But the laws of equilibrium had not yet been satisfied. The U-505 was heavy, sluggish. The stern was sagging deep into the water, dragging the boat down by the tail. The boarding party had stopped the influx, but they had no way to remove the 40 tons of water already sloshing inside the hull. They threw the switches for the main bilge pumps, expecting the electric motors to whine to life. Nothing happened. The silence that followed was more dangerous than the water. The voltmeters on the main electrical panel read 0. The German crew had left the batteries completely flat. The electric pumps, the only machines capable of expelling the massive weight of water in the bilges, were dead iron. The boat was sealed, but it was essentially a waterlogged stone drifting alone in the Atlantic. And without power, there was no way to bring it back to the surface. The math of the salvage operation had hit a hard, unyielding wall. The boarding party was frantically working hand-operated portable pumps, known in the Navy as handy billies. These devices were designed for putting out small fires or draining a flooded launch, not for emptying a combat submarine. A handy billy can move roughly 60 gallons of water per minute at maximum exertion. The U-505 had taken on 40 tons of seawater. At that rate, it would take the exhausted sailors over 11 hours of continuous pumping to clear the bilges. They did not have 11 hours. The U-boat was riding dangerously low, the stern awash, creating an unstable center of gravity. One large wave could roll the vessel over, sending the Americans and the intelligence trapped inside to the bottom. To save the ship, they needed the main heavy-duty bilge pumps. These were industrial beasts capable of moving thousands of gallons per minute, but they required high-voltage electricity, and the U-boat's massive lead-acid battery banks were chemically dead. The German engineers had ensured the cells were drained before they abandoned ship. Without battery power, the pumps were just cold iron, and without the pumps, the ship was a coffin. Enter Commander Earl Trosino, the chief engineer of the carrier Guadalcanal. Trosino was a salvage expert who viewed ships not as military assets, but as complex thermodynamic systems. He boarded the captured U-boat and assessed the situation with the cold logic of a machinist. He looked at the silent diesel engines and the dead electric motors. He knew he couldn't start the diesels. The compressed air flasks needed to crank them were empty, and the complex German valve systems were a mystery. But Trosino understood the fundamental relationship between motion and electricity. A submarine's drivetrain is a reversible equation. In normal operation, chemical energy in the batteries flows into the electric motor, which spins the drive shaft, which turns the propeller to push water. Trosino realized he could flip the equation. If he could force the propeller to spin, it would turn the drive shaft, which would rotate the armature inside the electric motor. If the circuits were set correctly, the motor would act as a massive generator, pushing electricity back into the batteries. It was a concept known as windmilling. But to make it work, they had to drag a roughly 1,100-ton Type 9C through the water fast enough to spin the shafts and wake the generators. The order was relayed to the towing ship, the aid fleet tug USS Abnaki, which had relieved the Guadalcanal of towing duties. They needed speed. The Abnaki surged forward, the thick steel tow cable groaning under the tension. The U-505 began to plow through the swells, its bow burying itself in the foam. Inside the humid, reeking engine room of the U-boat, Trosino and his team watched the main propeller shafts. At 5 knots, they were stationary. At 8 knots, they shuddered. As the speed climbed past 10 knots, the force of the water rushing past the hull grabbed the blades of the twin propellers. Slowly, agonizingly, the heavy steel shafts began to rotate. The physics of induction took over. As the copper windings inside the motors spun through the magnetic fields, electrons began to flow. The salvage crew watched the needles on the main switchboard. They flickered, then climbed. The voltage was rising. The dead submarine was waking up, cannibalizing its own momentum to generate life. Once the voltage stabilized, Trosino slammed the breakers for the main bilge pumps. Deep in the bowels of the ship, the electric motors hummed to life. The sound was mechanical music. The pumps primed, and suddenly a thick stream of oily black water began to discharge overboard. The plan was working. They were trading forward velocity for buoyancy. But this solution created a new, terrifying variable. To keep the batteries charging, they had to keep moving at high speed. But the U-boat was not a passive barge. It was a hydrodynamic shape designed to dive. As the speed increased, the dive planes, which were jammed in a downward angle, began to bite into the water. The faster they towed the boat to save it, the harder the ocean tried to pull it down. The physics of towing a vessel rely entirely on the principle of symmetry. When a ship is pulled through the water, the fluid dynamics must be balanced on both the port and starboard sides to ensure the hull tracks in a straight line behind the tow ship. But the U-505 was not a symmetrical object. When the German crew abandoned the boat, they had jammed the rudder hard over to the right. They intended for the submarine to circle endlessly until it sank, ensuring no enemy could board a stable platform. Now, that jammed rudder was turning the salvage operation into a lethal geometry problem. As the fleet tug USS Abnaki increased its speed to generate the electricity needed for the pumps, the U-boat ceased to be a passive dead weight. The water rushing over the angled rudder plate generated lift, exactly like the wing of an airplane, but in a horizontal direction. The submarine began to shear wildly to the starboard side. It was no longer following the tug, it was trying to overtake it. This phenomenon is known in naval engineering as kiting. The U-boat swung out to the side, pulling the heavy steel tow cable taut until it was singing like a violin string. The tension on the wire skyrocketed. The Abenaki was now being dragged sideways by its own burden. This created the most dangerous scenario in towing, the tripping hazard. If the tow line pulled the tug's stern sideways with enough force while the tug's bow was driving forward, the lever arm could capsize the surface ship in seconds, rolling it over and drowning the crew. The captain of the Abenaki watched the inclinometer on his bridge tilt dangerously. He ordered the speed reduced, but slowing down meant the U-boat's propellers would stop spinning, the batteries would die, the pumps would fail, and the sub would sink. It was a paradox. To save the sub, they had to go fast. To save the tug, they had to go slow. There was only one solution. They had to center the rudder of the U-boat. Commander Trosino gathered a small team and scrambled back down the hatch of the captured submarine. They had to navigate the length of the boat, moving from the control room through the narrow, dark passageways, past the diesel engines, and into the aft torpedo room. This was the most claustrophobic section of the vessel, tapering down into the cone of the stern. The air was foul, thick with the smell of battery acid and stale diesel. In the extreme aft of the compartment lay the electric steering motor and the hydraulic rams that controlled the rudder. Trosino shone his flashlight on the mechanism. The heavy steel rams were fully extended, locking the rudder hard right. The electric control system was dead, and even if they had power, the limit switches might have been smashed by the German sabotage. They had to do it mechanically. The team located the manual emergency steering gear, a heavy iron handwheel that looked like a valve from a steam locomotive. But fighting the hydraulic pressure of the ocean pressing against the external rudder plate was nearly impossible. The water flowing past the hull at 10 knots was exerting thousands of pounds of force on the rudder, pinning it in the turned position. Trosino realized they needed to bypass the hydraulic resistance. They located the relief valves on the steering rams. With a wrench, they cracked the valves open. Hydraulic fluid hissed out, depressurizing the system. The connection between the rudder and the rigid piston was severed. Now the rudder was free-floating. The men grabbed the manual handwheel. With the hydraulic lock broken, they used brute mechanical advantage to crank the gearing. Inch by inch, the indicator needle moved from hard starboard toward midships. Outside, the effect was immediate. The hydrodynamic lift vanished. The U-505 stopped its violent shearing and swung back into line behind the Abenaki. The tow cable relaxed into a gentle catenary curve. The tripping threat was gone. They could now ramp the speed back up, windmilling the props and keeping the pumps roaring, dragging their prize toward the horizon. 1,700 nautical miles. That was the distance between the capture site off Africa and the U.S. Naval operating base in Bermuda in the Great Sound. In the world of marine salvage, towing a disabled vessel across open ocean is considered one of the most hazardous operations possible. Towing a captured enemy warship filled with unexploded ordnance and top-secret cryptographic equipment through a combat zone infested with U-wolf packs was a suicide mission. The convoy moved at a crawl. The USS Abenaki, straining against the dead weight of the German submarine, could barely manage 6 knots. Every mile was a calculated risk. The salvage engineers knew that the U-505 was not watertight. The shaft seals were leaking and the hull valves were stressed. If the pumps failed for even an hour, the boat would regain negative buoyancy and snap the tow cable like a thread, plunging back to the abyssal plain. But the greatest danger was not hydrodynamic. It was strategic. Admiral Ernest King, the chief of naval operations, had issued a directive that was absolute. The capture of the U-boat had to remain a ghost event. If the German High Command learned that the U-505 had been taken intact, they would assume their Enigma codes were compromised. They would instantly change the encryption rotors on every submarine in the Atlantic, blinding Allied intelligence and resetting the war effort. To maintain this illusion, the task group had to practice extreme deception. They could not use standard radio frequencies. They had to assume that every horizon held a German periscope. If a fellow U-boat captain spotted the U-505 under tow, his standing orders were to torpedo the captured vessel immediately to protect the secrets inside. Even worse, Allied patrol planes flying from the Azores might mistake the silhouette for an active enemy and bomb it. The hunters had become the protectors of the very thing they were built to destroy. For 15 days, the convoy limped west. On the submarine, the skeleton crew lived in a world of tilting steel and stale air, monitoring the voltage of the jury-rigged charging system. They were riding inside a trophy that was constantly trying to kill them. Finally, on June 19, 1944, the convoy approached the Great Sound of Bermuda. This was the final hurdle. The entrance to the harbor was a navigational nightmare of coral heads and shallow channels. The U-505 drew nearly 16 feet of water. If they ran aground now, the hull could fracture, spilling the codebooks into the silt. Captain Gallery ordered the formation to tighten. The Abnaki shortened the tow wire. Slowly, the gray shape of the U-boat glided past the anti-submarine nets. As they entered the harbor, a massive floating dry dock was waiting. The engineers flooded the tanks of the dry dock, sinking it deep into the harbor water. The U-505 was maneuvered directly over the submerged blocks. This was the moment of truth. If the boat was not perfectly centered, the keel would crack as the dock rose. Divers went down to check the alignment. They signaled the surface. The pumps on the jumbo roared to life, pushing water out of its ballast tanks. Slowly, the dry dock rose, lifting the German submarine out of the element that had hidden it for so long. As the water drained away, the full shape of the hull was revealed. Covered in barnacles, draped in seaweed, but intact. The hatch was opened. Intelligence officers, not salvage crews, were the first to enter. They bypassed the machinery and went straight to the communications room. There were code books, charts, and signal tables, the kind of paper that could steer convoys away from death. They had the grid maps. They had the acoustic torpedo diagrams. They had the entire nervous system of the Nazi submarine force. The salvage operation was technically complete. The physics had held. The secret was safe. The capture of the U-505 was a tactical masterpiece, but the strategic victory depended entirely on silence. In the summer of 1944, the United States Navy performed a vanishing act. The 58 German sailors who had survived the boarding action were not treated as standard prisoners of war. They were classified as non-existent. The logic of counterintelligence is colder than the Atlantic. If one letter, one Red Cross notification, or one rumor escaped back to Berlin, the German High Command would realize their submarine had not sunk. They would assume the Enigma keys were compromised and reset the entire naval encryption system. To prevent this, the German crew was transported to a secret detention center at Camp Ruston in Louisiana. They were isolated from all other prisoners. They were denied male privileges. For the remainder of the war, their families in Germany believed they were dead, lost at sea with all hands. It was a psychological quarantine designed to protect a mathematical advantage. While the men sat in silence, the machines went to work. The codebooks and the Enigma machine recovered from the radio room were rushed to the cryptographic center in Washington. The impact was immediate. Allied cryptanalysts gained new leverage, even cracking special coordinate codes that had resisted them before. The convoys were no longer sailing blind. They were routed around the waiting wolf packs with surgical precision. Naval historians estimate that the intelligence gleaned from the U-505 saved tens of thousands of tons of Allied shipping and shortened the war in Europe by weeks, perhaps months. But as the war ended, the U-505 ceased to be a crown jewel and became a liability. The technology that had once been terrifying, the acoustic torpedoes, the high-pressure hull, the complex diesel valves, was now obsolete. The United States Navy had entered the atomic age. The submarine was towed to the Portsmouth Navy Yard in New Hampshire and left to rot. For nearly a decade, it sat in the brackish water, a rusting iron carcass stripped of its dignity. The interior, once the scene of a desperate salvage battle, was now peeling paint and stagnant air. By the early 1950s, the Navy had little use for the captured boat, and the talk turned toward disposing of it at sea. The U-505 was scheduled to finally receive the death it had cheated in 1944. This time, the salvage operation was not driven by military necessity, but by history. Captain Daniel Gallery, the man who had ordered the boarding party, was now an admiral. He refused to let his prize be sunk as garbage. He leveraged his rank and his connections to broker a deal with the Museum of Science and Industry in Chicago. The Navy agreed to donate the boat, but with a catch. The museum had to pay for the transport. Moving a roughly 1,100-ton steel cylinder from saltwater to the American Midwest was an engineering nightmare that rivaled the original capture. The submarine had to be towed 3,000 miles through the St. Lawrence Seaway and across the Great Lakes. Once it arrived in Chicago, the engineers faced a final physics problem. Submarines are designed to float in water, not to sit on land. The point-loading forces of resting a hull on concrete blocks can crush the steel plates just as easily as depth charges. In 1954, a massive floating dry dock carried the U-505 to a man-made beach on the shore of Lake Michigan. Engineers constructed a rail system of steel rollers and cribbing to distribute the weight. Using heavy winches and greased skids, they dragged the boat out of the water and across Lakeshore Drive in the middle of the night. It was a surreal spectacle, a Nazi warship crossing a frantic American highway, stopping traffic as it made its final voyage into retirement. Today, the U-505 sits in a climate-controlled underground bunker hundreds of miles from the nearest saltwater. It is fully restored, a time capsule of 1944. But for the salvage engineers who look closely at the hull, the story is not about the museum lights or the interactive displays. It is about the sea strainer cover in the rear engine room, the one Zenon Lukosius threaded back on by touch while drowning in oil. It is about the jammed rudder that nearly capsized the Abnaki. It is about the sheer mechanical audacity of the men who decided that the laws of physics were just another enemy to be outmaneuvered. The ship is dry, but the engineering truth remains. They didn't just capture a submarine, they captured time itself.